All right, hello everyone. So welcome to CompSoc's first STMU that is in person in the past 2 years. So can we get a cheer for that? All right, so today we have two great speakers. We have James Rheard from A&D Digital, and we have Victor Kaluza from Edinburgh Uni, speaking on behalf of SIGINT, talking about an introduction to malware. So, James Rheard.
Hello everyone. By the way, if anyone, take this off. If there's any issues with displaying the screen, if there's any issues with the mic, genuinely just heckle up. It's quite weird to walk up in silence, but hello everyone. So today, what I'm going to be doing is talking about complicated software. I think on a lot of the materials and stuff, I'm going to always talk about testing and stability. First of all, this is the first time doing this in person. I assume this is the case for the society as well. It's kind of quite strange to go from having like talks where it's online and participants are on the screen, and now it's everyone in person. So this is great, but also slightly nerve-wracking, but awesome. So today, what I'm going to be talking about is developing complex software. So today, I want to talk about welcome an intro, insight in testing and resilience over the years, why testing is important, different types of testing techniques, a little bit about chaos engineering, process and approach, and Q&A. Hopefully, a lot of this stuff is relevant. If there isn't towards the Q&A at the end, just let me know if there's anything in particular you're kind of interested in. I know there's a bunch of different specialities in the room, different fields, but predominantly, there's going to be the perspective of being a software engineer working in a consultancy. So my name is James. I'm a product developer. Basically, I'm a full-stack software engineer. I work at Edinburgh Club Somerville. That's our office. Worked across a number of different sectors, education, health, predominantly finance at the moment, and then essentially retrained most recently about 5 years ago to become a front-end engineer. The most eagle-eyed amongst you have noticed I'm wearing the same clothes when I took the photo. It's purely by accident. What I'm really interested in a lot of the time is kind of how technology emerges into a lot of different sectors. So I'll come from the perspective a little bit of being a software engineer, being a product developer, done it for about 5 years, but I've worked in different sectors before. So one of the different environments I worked in is customer service. I worked in office management, really just jumping across different positions in most of my 20s, so that's my perspective. So I'm going to talk about testing and stability. Hopefully, my hope is that the thing that you kind of take away from this is something being useful, something about testing stability. If you're building your software or you're thinking about construction within a team, there's something you can take away from it. If not, genuinely tell me at the end of the Q&A. I'm super fascinated to see from different perspectives. I'm literally from the perspective of someone who's retrained, self-taught. I didn't have a computer science degree at all. So yeah. So, testing and stability, what is it? Why do we do it? What kind of tests do we do? Why is it so crucial? What can you do outside testing? By the way, I believe I'm running for about 50 minutes. It's kind of a weird sort of time. So if you feel like you want to step outside, come back in, I'll still be talking, so it's absolutely fine. It's kind of a new thing to be in person, trying to figure out the social etiquette for it, but absolutely fine. And that's what we're going to be running through with the testing stability. So this is kind of a strange overview in terms of the basic history of what I view as like consumer electronics, people who consume web applications and devices. But I kind of want to get this perspective of we've gone through quite significant rapid change. So the iPhone, the HTC Dream, which was the first Android phone, this is about 2008, 2007. I know the iPhone was released in 2007, and then it was quite an expensive product. It was relatively limited, but it was quite a big deal. And that was the same for the HTC Dream. It's a little bit under the radar, but what they've grown to be is super kind of accessible tools for anyone to use. So I know that I would broadly say in this room, we're all quite tech savvy and quite used to accessing different forms and different operating systems. My perspective is always about your mum or your dad or your aunt or your sister, people who aren't particularly tech literate. And Facebook was a huge factor in that. So not only was Facebook predominantly for like your desktop, but then it became something that was pretty much accessible to everyone. Now they've become a massive company. And everyone uses it. And it's pretty kind of crucial in how we communicate to each other. And then at the bottom, we've got the International Mobile Telecommunications Advanced Specification Set. That's basically 4G. So if you are used to, obviously, the idea of like 3G, Edge was possibly the point before it. 4G, what that allowed was to have quite high speeds of using your mobile device, and it was quite accessible. And what that means is there's been a rise in consumer-facing products. Basically, if you have limited technological knowledge, you can use them. You know, we mentioned Facebook, but pretty much everyone uses Twitter. Through the pandemic, everyone's been super used to ordering and shopping through Tesco or have it delivered or what have you. It doesn't have to be a barrier anymore that you are not particularly familiar with how it works in the back end. What kind of front-end application is being used for it. Essentially, the consumer-facing products have just gone through a massive change of like, this works or doesn't work. And the speed and the adoption has been pretty rapid. I mean, if you consider it as well, it's been from 2008 to now, that's about 13 years, and even the initial part of it sort of sped up. It's been quite, for the fact it's relatively been around a decade, been pretty speedy. So, a couple of the industries that are known for kind of like these growing tech industries, health, financial services, Internet of Things, your Ring camera. Again, the perspective isn't necessarily people who build it, it's going to be the perspective of people who use it. And if you're looking at health, financial services, in fact, all of them, they're not going to be people who are familiar with how it works. It's just the fact that they want it to work. So quite a number of us, I would hope, at some point ordered a lateral flow test, ordered some sort of PCR test in person. That is your government services. That's going to be NHS products. What I hope to stand out from this are these are fundamental industries that are kind of crucial to how we do things now. So my takeaway from that is security and stability is absolutely vital, absolutely crucial. If anything goes down in terms of your, let's say you have, one of the growing things in Edinburgh, particularly at the moment, we have a couple of spare seats this side, if anyone wants to come this side. I don't want you all bunching up in that corner. I mean, you can bunch up if you want, but there's actually seats over. Good stuff. So yeah, basically, health, financial services. Imagine, for example, if your Ring camera at your house, let's say, went down and then there was a burglary, right? These have become crucial part, primary communication. If your FaceTime goes down and you're desperate to call your family or just call a loved one, that's pretty crucial. Security and stability is vital. So what I'm going to do a little bit is I'm going to run through some of the kind of testing we do at my position. So I'm a full stack developer. For the most part, it kind of broadens out. I work as a client with &Digital with a large financial client. There's only a handful in Edinburgh, so you can make an assumption about which one it is. But what we do with this large financial client is we have a number of tests. So we have unit, integration, and acceptance. Now, in terms of the unit and integration, we use Jest. And I'll give it a little bit of an example of kind of how we do that. And then I'll go through our acceptance tests. Sometimes you might be familiar with end-to-end tests. And this is predominantly if you're working with front-end. Unit tests. So let's give a bit of a demo. Give it a try in person. Right. I'm very tall, so I'm trying to figure this out at the same time. So, cool. So I know it's slightly difficult to see. Is that a bit better? Can everyone see that? Yeah? Cool. So what I want to illustrate, oh, I know, I'll talk it through first. So what I have here is a simple addition function. Now, I'm going to assume quite a number of you understand what an addition function is. It's overly simple. Basically, I wanted to illustrate was there's a purpose of the function, single purpose. You put in two parameters. I'll wait for the ambulance to go by. Cool. You put in two parameters, and that adds them. Now, I think if I'm trying to illustrate what the purpose of unit tests are, this is not exactly something that we come across regularly, but it's I want to illustrate a purpose. So, what we have, again, it's slightly weird that it's massive, but what we have is we have simple tests to say, does this work? Is this something that's going to work? I've passed in addition, those two parameters expected to be 3. Again, it's stupidly simple. But what happens if you write your unit test as well, what if I do that? I have a built-in plugin for VS Code. What it does is anytime you make some sort of modification with either your unit test or with your code, it runs those tests. It's not actually dependent upon any additional services or external factors or anything like that. So it just runs it pretty much every time. But you can still run the test as well. So now I've brought in one simple unit test, slightly more complicated unit test below it, and expect it to be 123. But what usually happens is I then go, well, we have a success, we have an error. Have a success and an error. If you notice I bring that in, it should throw an error. What happens is when you write your unit tests, or actually hands up, who's worked with unit tests before? Good portion of you. Who's never heard of unit tests before? That's absolutely fine. Basically, the idea with the unit test is that you have a small portion of your code, whether it be a function, whether it be something relatively small. If you go along with the solid design principles where it's kind of modular, then you can test those small portions of code that you add and modify. So usually what we do is we have success, and we have an error state, and within the error state, we like to manufacture different things that I might consider might go wrong. So if you pass in a string and a number, that's not going to be a normal case scenario, but we want it to fail. We want to have some response for it. So what I want to illustrate a little bit is when you write tests, it often then makes you reflect on what the code you've initially written before. So obviously above, if I bring this in, please forgive my weird stance. It's kind of a strange position to be in. There we go. So what I brought in there is just some sort of error handling. If a parameter within either A or B is not a number, just throw an error. Now you could do it where it has a different specific response. It responds with a string or something like that. For this case, we usually throw errors because we do a lot of try catches. We work a lot with get requests and post requests and what have you. And now you notice that the test passes. And that's quite nice because it then becomes sort of an iterative process. Does it work? Does it not work? Add error handling, error conditions for it. That's quite nice. What should I touch on now? I'm going to try having integration tests. Hands up, who has heard of integration tests before? A couple of you as well. I'll only ask you to put your hands up a number of times. It won't be throughout the entire thing. Basically, integration tests, imagine if you've got multiple services. So let's say you have a service on your front end, talks to your back end, or let's say you have multiple back ends that talk to each other. What you want is you want your service to try and behave in a way that is kind of expected. You built it to do a certain thing. You expect it to have certain logic that behaves a certain way. Therefore, you should write your test to try and interact with something. Now, I'll be completely honest with this one. I haven't written it because I wanted to see what was... Yeah. So this is a simple try-catch. It's an Axios get that does a get request, then has a then catch. The catch, if you're not familiar with it, is just if there's an error response. Right? What it does is then it does a get. Usually when you do a get or a post within your application, there's a certain amount of logic that you want to do. So let's say, for example, if you do a GET request. You do a GET request, you fetch some data, either an object or an array or what have you, and then your application will then behave in a certain way. And usually this is what we're doing. We're testing to see that what we've written it for does the purpose we want it to do. So I'll give you an example of what we're doing at the moment. So if I come out to this, Postman, hit send. This is obviously running locally, and all this is nonsense, and this is pulled in from a GitHub, but it does basically what you have. You have a GET request, it returns with some gibberish, but it works. So how do we test that? Well, if we look here, I think that one was the controller. No, it was the service. So what you still have is you have some mocking in this one. So usually when you do your tests, whether you do your unit test or integration test, at some point you're going to have to deal with mocking. Mocking is pretty vital because you can't spin up services all the time. You can't spin up your dependencies all the time. So you need to mock a lot of them. Now, if you're familiar with Docker, what we usually do with our large financial client, we spin up a Docker container. It has multiple, a Docker service, sorry, it has multiple containers. And we test if they communicate to each other properly. So we might have one which is a mocked service. We have it talk to another one. And then if the expected behavior, once we have a correct response, is the way we want it to, that's pretty good. Let me see if I can actually remember what the command is for this one. It's, do I actually have it? Test, there we go. It's pretty simple. So if you see, it runs the test at the bottom. It's very similar pretty much as you would have with unit tests. Is it testing something, it runs, is it successful or not? Usually, again, you would have a mocking of this would be you are basically mocking the response. So the response here is going to be a data of an empty array, an array with a couple of objects. It's going to resolve itself because you get a mock implementation, await it, so it's a bit of a promise. And then you expect the actual, which is the response from the service.list here, to match to the response.data. It's really, really simple. We have a preference for where we spin up Docker containers, have a mocked service that just has a wire mock that responds to it. Or you can mock it. I have that preference for that because I like the idea of something spinning up and working the way it should do if you're in production. But again, I think a little bit that can be a bit debatable and comes down to preference. Does that make sense so far? Is that all right? Cool. And the final one we do a lot is acceptance tests. We use Cypress. Now, we've developed a number of applications for our large financial client. They could be APIs, they could be front end, so we actually mix and match the kind of testing we have. So I'll show you my, oh, it's here. So I built this with GraphQL. It's absurdly simple. If I go over to here, get my Firefox up. So basically, it's a hello button, if you couldn't tell. It's a simple button that when I click it, hello to you too. That's all it is. It's a hello button, does one action, has a little bit of logic. It's absurdly simple. Again, you might be thinking, why am I displaying these absurdly simple things? I'll make that point a little bit again in a second. But if I then remember what the command is, run test. No, it's not test. It's down here somewhere. Test acceptance. Am I in the right one? No, no. Cool. So this has not worked a number of times, so if it doesn't work, it's expected. So if we go over to here, what it spins up is this, what's called a Cypress test. Again, for this piece of logic, the testing you're going to have is going to be pretty simple. You run it. It does open it this time, which is great. Loads of the tests. We're going to check if there's a hello, if there's a button. And if we click the button, is it expected behavior? So if you look at the tests themselves, integration spec, this is how you write them. So it's simply just visit this location. Does it contain the string that you want it to? Does it have the button that you want to that contains the string? And the button, it says, get the button, contains hello, click. And it should then say hello to you too. Now, again, I want to reiterate, this is not necessarily the kind of test that we do because it is absurdly simple. However, what I wanted to illustrate here. Yeah. Right. Gone through that, gone through that, gone through that, gone through that. Why test? So, if I'm going to give you the context about what we talked about there, it's get post requests, it's a button that says hello. What was the other one? It was a unit test for addition, right? Pretty simple because we're in the context of it. If you're at the bottom, for example, if you're building this grand mausoleum? Yeah, okay. If you're building this grand piece and you work on a simple part of your Lego kind of blocks of code, then you're going to remember it because it's going to be the context of it. The small part at the bottom, you'll say, I know where this block is, I know the behavior of the block, I know exactly what it's doing, I'm in the context of that. The thing I want you to consider, regardless of what kind of piece of software you're going to be working on developing, is what happens when the complicated sort of aspects of it change. A month or two down the line, you're going to forget what that initial block of code was going to do. So the addition thing is relatively simple now because it's a simple function. You're going to have multiple error states for it, you're going to have multiple sort of behaviors of it. Hopefully, if it's solid, it's decouplable. But you are not, it'll take you, or it certainly takes myself and my team, a good like half an hour sitting through and going like, what was this? What was the context of this? I can't quite remember the specifics of what we were working on, and it takes a little bit of a while to refresh. That context switching, particularly when you're working on deadlines, when you're working with clients, when you're working with different environments, when you're working on different requirements, can be a real challenge. And what this does, context switching, yeah. So if you're working on context switching, that's kind of a pain. Try and limit that as much as you can. It's kind of unavoidable a lot of the time. Time spent not testing will be displaced elsewhere. So there's this usually assumption if you're working in like a position in a startup or you're working in a larger organization that sometimes you want to go, I need this done, I need this ticket done, I need this work done. Time spent not testing will then be displaced elsewhere. And by that I mean, if it's your 9 to 5 and you're working or something like that, that is actually a relatively decent time to be working on your testing. If you're not going to be doing that testing then, usually it manifests itself late on like a Friday in the middle of the night, and it's not ideal. And your first port of call is not, how is this working exactly how I want it to? Because it doesn't. You just want it done. You want it fixed, you want it done. Knowledge becomes individualized. So I assume that quite a number of intelligent people in this room, if they change and chop within a team, that can be a problem. Because if you have someone who is exceptionally talented, we call it at work the nuclear bomb. Let's something's on fire, right? Let's say there's an incident or an emergency. We have 1 or 2 people that we can throw into that situation that they can then say, oh, they'll fix it, or they'll fix it. In that situation, you are then relying on one person to fix it continuously. What you want is kind of like a holistic approach for a team. I choose a lazy person to do a hard job because a lazy person will find easy ways to do. Bill Gates is fine. I'm not entirely sure about him as a person, but I always like this as a quote because the idea's approach is that even if you're passionate about software engineering, you shouldn't be massively passionate about your job outside of like your hours. Basically, your job is for contractor-like sort of purpose. Outside of your time, your free time, that's quite valuable. You should always aim to make it as easy, as simple as possible for people to approach complicated problems. Automation is a big part of it. So you can run it locally. So you can have like things like Husky, pre-commit hooks. When you commit something, it can then run through those integration tests, those unit tests. If you can run it remotely in the pipeline, that's pretty good too because that becomes a blocker. If you have something that you're going to deploy to the prod, for example, you want to know it's broken soon. You want to know it's broken before the user uses it. Whatever purpose it is, whatever it is, you want to know at that time. Processes. Who has done pair programming before? Nice, cool. Carry on doing that, especially when it comes to PRs. What happens particularly, oh nice, cool. Sorry. What happens when it comes to pair programming and PRs is often, particularly since we've done it remotely for the last 2 years, we do like some sort of like email tag at a time. How long have I got? I can break it for Peters now, if you want. No. Okay, right, that's fine. I'll try and rush through it then. So pair programming, when it comes to PRs, is really, really useful because then you've got someone in the context of what they're working on, and then they can communicate it to you. And the idea of them telling you a story about how to do it is far simpler than you trying to parse through, why has the package JSON dependency changed? Why has this name been changed? Why has this const been changed? All that kind of stuff. You can ask them the questions there and then. It's speedy, and it makes you kind of upskill as well. Sanity checks all the time. I run through stuff where it's like, am I going in the right direction? Is my teammate going in the right direction? Is the approach for this the correct one? No ego approach, broken windows. We use that term a lot, which is broken windows. If it's broken there, fix it, because then it builds up. I'm not entirely sure the specifics of the broken windows, but in terms of getting something fixed, it's far better to get it fixed then. Again, it's that displaced time thing. Down the line, you might have something that's broken in prod. Again, at like 3 o'clock in the morning, it's some weekday. It's far simpler to amend it and fix it then. Documentation. Documentation is quite boring. It's quite dry. It's quite annoying to modify. But what if your nuclear bomb or your star developer or whomever then decides to move on to another company? What happens if they get ill? What happens if something happens to them? That is the thing where you want to have that documentation that lives somewhere. Essentially, if something's broken and you are relatively in a good position, you'll go on some sort of like hunt of different documentations and interpret it. Usually that's what we do a lot of the time, is we try and interpret what people were writing and make sense of it. It's far better than nothing. So I'm not entirely sure particularly if there's going to be some like political backlash to this stuff with you folks, but there might be a case where there will be. So if you're thinking about testing in terms of what you build, it gives you far more predictable time estimates. So if you like take a TDD approach, which is test-driven development, we have a TEDD approach, which is test-eventually driven development. Let's say you have a service and you want to change it up or you want to modify it, and someone comes to you and say, how long will this take? How long will it take for me to chop this out and change it out? All you've got is your individualized knowledge. If you then change it out and then you see, well, all these tests are broken, it's not perfect, but you've got an evidence-based approach for like, this will take a month, or this will take 2 months. It's far better than nothing. Your team just builds faster. It doesn't seem like it because you spend so much time trying to figure out how the mocking works. How the hell does this mocking work? I have no idea why this dependency is being mocked. But it's far better, and I've been in both situations where you're trying to figure out the testing and you have no testing. The place where you're figuring out the testing is far better, far speedier for your team than to have very little testing at all. On one hand, you have something where you're building on some solid foundation. On the other, it actually feels like you're building on sand. And it gives more certainty. It gives more certainty that what you're building actually works, it behaves the way you want it to because there's automated tests. If it's not tested, it's not done. This was actually a quote from our QA. Our QA is pretty stubborn, wants to know if it works the way it wants to. It can be pretty damn annoying, but it's right, because if it's not tested, it's not done. And that's the way you approach it as like a team. It's not done by having it be displayed to the user. It's not done if it actually does get a post request. It's done when the tests are written. And if something can go wrong, it will go wrong. So this is a little bit my transition, because I've done that talk previously about testing and stability. One of the things I'm fascinated by is chaos engineering. What happens in production? Now, it's less scary when you're learning to write software engineering because you can just show your piece of software, whatever you built, to your friends, and if it doesn't work, it doesn't work. But in production, when you have a couple thousand people, a couple million, and then you've got like the politics of stakeholders rightly saying like, why is this broken? It then becomes quite anxiety-inducing when you have to think about, is the way I'm testing it, is the way I've built it going to work the same way it's going to work in production? How much confidence can we have in complex systems that we put in production? And if you're unfamiliar with chaos engineering, basically, it's the discipline of experimenting on systems in order to build confidence. What that means is you perform small little experiments on what you built. You're basically breaking them. In safe, kind of controlled environments, you're breaking them. What you do is you build a hypothesis, you build very real-world events, run experiments in production, automate it, and minimize the blast radius. And what the key thing about this is CHAP. So Netflix uses CHAP. It's basically just any time you have regular automated sort of chaos experiments in prod. I don't think it actually necessarily does it when you do a push or a commit, but it does it on a regular enough basis, and then you get reports back. One of the key things I want to sort of focus on, only run during business hours. That's a really crucial part of it, because if you run that when something's on fire, like the second point here, you don't want to pour petrol on the fire. You want it to be within a controlled blast radius, and you want it to be there when you're in a mindful state and understanding what the problem is and have the space to understand that. Also, the bottom detects excessive customer impact. So essentially that means if something's really fundamentally wrong for the customer, it'll then kill it. So you have, what this comes from is, I believe it was a Netflix article that they wrote themselves. Who else was going to write it? I don't know. But you have the gateway, you then have 1%. You have a control, and you have an experimental thread on that. What the crucial thing is, if you use Netflix, it's not going to be 50% of your production. It's not going to be like millions of people. It's not going to be thousands of users. What this would then filter off into is that 1% then becomes the control and the experimental. What this was, I believe, was for the rating system. So wanted to introduce a new cluster of sort of rating system for it to use. And they wanted to test, well, if we bring in this whatever we built into production, it'll still function the way we want it to function. So what you have is a control, and you have the experimental branch. The experimental branch is fundamentally where you place the change. So what you have, I believe actually this one was from when users were testing about if they were hitting a play button and then the latency on if there's a huge enough latency between the two. But what you have then is this sort of measurable, safe, controlled environment to know, is this going to work? Is it going to sort of, if it then has that latency between the two of them is too wide, and you as a user get impacted, then it just kills the experiment. I pitched this to the stakeholders of the large financial client, and they seemed relatively responsive to it, but for me, I just really enjoyed the idea of having something additional in production on top of your testing, on top of those sort of measures to check to see what you've actually deployed works. The other thing is that what they do, literally with this, sometimes they just kill servers. They'll kill clusters, and they go like, what happened? And it's a nice way to have that controlled blast radius rather than just something broken when you don't want it to break. I'm actually running a little bit ahead. I can expand a little bit on the process, and hopefully there's a few questions. Couple things. Shared learnings regularly. So lunch and learns, lightning talks. You'd be surprised a lot of companies that don't do that. A lot of places don't do that. That shared sort of culture, I think obviously you can have that at university or educational facilities. It's quite a challenge to have that at a startup or at your job. But once you have that culture of sharing that knowledge. So let's say we have someone who's really passionate about Gatsby. We have regular talks about Gatsby. We have regular talks about data lake on AWS. Even if something is not necessarily applicable for what we work with on client, it's always super useful. And if you're not great with doing talks, or you're not great with doing those kind of things, lightning talks are like a 15-minute or like a 5-minute sort of presentation. And that's quite a useful, nice place to learn how to talk, learn how to communicate those things. Align with solid principles. I heard a great analogy about it. So it's if you build your software where it's sort of interwoven and connected, almost like knitting, like some sort of thread or something like that, it works and it's good, but what then becomes a problem is that it becomes really difficult to decouple that. It becomes a real challenge to then say, well, I want to change this service, or I want to change this dependency, or I want to modify this part or that part. The solid principles essentially is trying to keep it modular, single purpose, actually trying to remember what it stands for, I can't remember what it stands for, but the approach is that you keep it kind of separate, modular. User research. Who has done user research before? Significantly less people have done user research. Hopefully you will come across user research in different sort of points of work or what have you. User research essentially is placing something in front of the user and then saying, does this work? They will say, like, can you sign into this? Can you click on this button? Can you order me like flowers if it's like a flower shop? Can you order me like this item? Can you set the delivery date for this? Really basically simple. You'd be surprised actually how very accomplished developers will build something that no one can work. And what user research essentially is putting it in front of people who will use it on a regular basis and go like, do this, do that. It will save you massive amounts of time by having someone just to play with it. Even if it's your own personal project, even if it's something that you think might work, once you put it in front of people and get that reaction from them and then test it with them, that actually works really well. And we're real passionate about Scrum. We have sprints, we have Scrum ceremonies of like retros, reviews. We have clients, so we then present them in those reviews about what the work we've done. What the point of it being is that you have a regular, frequent processes that go like, is this the point in which you wanted this to be? Is this the right direction we're going in? It's a little bit of a science check, but it's far more complicated than that. So Scrum ceremonies, daily stand-ups, keep it in check with everyone. That's pretty good. I think that's it. Yeah. Sorry, I ran a little bit over. Are there any questions? Yes.
If you're large financial organizations, so I think you're a large organization.
Yeah.
If the bank is here, I think they are. How did you convince them that doing something like Chaosmonkey might be a good idea? Because my parent company is also a large financial organization. I'm incredibly averse to any form of risk.
That's a great question. I would say that your experience is pretty much echoing my experience. I'll give you, firstly, a short answer. It's iterative. So we then have like kind of processes of working and ways of working that we say, like bringing in Scrum. Bringing in something where there's regular stand-ups and there's a review. That was the initial point of like this works and this will help you develop it. So that was an initial point of this works. You can build the trust with us. I read a book recently called Rapport, which essentially is to build up those lines of communication, even with people that you didn't necessarily disagree with, is pretty fundamental to get the way you want it to work. If you are convinced about this is the right approach, you're convinced about this is the right technology to use, even when it comes to stability in the long term, that kind of thing doesn't happen overnight. It happens where you try and build a relationship and iterate over it. I'm not going to say it works all the time, because it doesn't. What I will say is if you then have that level of trust where you build that product and it kind of works for them, and I'm not going to say it's going to take a long time, because it might take a long time, then hopefully you can build those lines of communication towards that approach. The large financial client that we work with is still quite open to change and different ways of working. However, it still has an issue with things like we try to deploy regularly, and that's an ongoing conversation. Is pretty fundamental, I would view. However, they've come from a different position of compliance and regulation, and the way they described it was that if something happened to their large financial client, the British economy would be down. There'd be a significant dent on it. And that's basically the level of like concern that they have about it. It's not necessarily like your Starling Bank or your Monzo, where I think there's actually a bit more of a culture of that. They've come from this sort of legacy approach, which is completely right because you've gotten this far. But I would say that comes a little bit from building those lines of communication, building those relationships, and trying to do that a little bit over time. So, any other questions? Yes. I'll preface that by saying that complicated doesn't necessarily mean at the forefront of what technology is. Usually, complicated testing involves a multitude of different dependencies that we brought in. Hopefully, it's not a huge amount because you've iterated on that and it works, and hopefully we've broken it down enough that it's a modular approach and enough to then test on it. So I actually can't think of an example from my current position, but thinking from my previous position, we used to do really long written tests that have a whole bunch of assumptions on the front end. So because it was a little bit of a monolith, and it wasn't necessarily the developer's fault because that's the huge amount of pressure when it comes to a startup. But I would say the most complicated thing might have been something like if you have an application that's got a lot of flaws, you then have to set up the environments for it. You then have to set up the right and kind of approaches for it. When you have React testing library, for example, you have to find the right tag, trying to write that out when stuff isn't kind of working. It's a little bit why you've got like a scaffold of like the Jenga game, but you're missing blocks, that sort of approach for it. And when you have that lack of foundation, it then becomes like, sorry, I can't really think of a specific example, but that's how I felt about it. Hopefully, you don't have to have that in terms of like regular kind of back ends and front ends, but the biggest pain often comes with trying to mimic that unstable environment that you've built it in the first place. So yeah. Any other questions? Yes?
You mentioned 3 different types of testing. Mm-hmm. Unit testing and one more. I forgot.
Acceptance?
Acceptance testing.
Yes.
Yes. And I was wondering because in first year computer science courses at Edinburgh, we also learn about something called property-based checking.
Yeah.
Which is a bit different to, I think, what you've showed us. And we were wondering, I was wondering whether you consider property-based checking in your docs, and if so, why? You chose unit-based testing.
I'm not familiar with property-based testing. No. What kind of testing is that?
So, for example, if we made a function to sort a list,
Yes.
and we test it by giving it any random inputs, and then just making sure that the output is always in the correct order, in a sort order.
Yeah.
Or that the length doesn't change, or some property that always holds regardless of any kind of input that you give it.
It sounds very familiar to unit tests. Basically, the only kind of answer I can give to that is it's industry standard in terms of unit tests. Property-based testing, I'm not particularly familiar with, but I'm also, it's kind of come through an industry of like being self-taught and then different companies. But unit tests it seems very similar. Jest is also very accessible, very sort of easy to use. Yeah, it's industry standard. But yeah, it's the first time I've heard of that. That's quite cool. Any other questions? Yes?
Testing does tend to take about as much time as writing the actual software.
Absolutely.
So do you and your team have any guidelines on making sure that development time doesn't spend too much on failure tests?
That's a really good question because I think, I guess what you're assuming is you then think, what's done in writing tests? When can we like forget about the error conditions when we've sort of fulfilled the point of it? So I'll preface that by saying testing, when we write tests, does take a long time. There have been a number of occurrences where we've written our piece of software and it takes us double the amount of time to write the tests for it. And it's just like trying to get mocking right, even when it comes just to the learning curve of trying to do that. when we don't spend enough time, how we counter the idea of spending too much time on it is by, usually there's a deadline, so that makes it pretty quick. It's like trying to get that down first. In Jest, actually, they have coverage. So it's not robust, but what it does then say is like, these lines of codes are uncovered. These lines of code are not being tested properly. Usually that's pretty good North Star in saying like, this is sort of what you're missing. This is the approach we have. If you do try and write unit tests or unit tests where it's 100% coverage, it's a complete waste of time. You're trying to get above like 90%. There's enough of a coverage to say we have enough confidence in this being stable. Short answer, it's your own judgment. It's up to your team. It's up to your sort of, if you have a team manager or someone manages you, that's part of the communication of it as well. If you have other developers, then usually there'll be consensus amongst you about that. It's kind of a complicated way of sounding like, it depends. But it's a great question, yeah. Any other questions? Yes?
How do you make sure that your testing results will give you the right application properly? You're doing like testing on your software, and how do you make sure that your testing gives you your final result? Like, it matches your goal.
Are you saying, how can I make sure that the testing that I'm writing matches up to the purpose of the software?
Yes.
Right.
How does it end up being your dream software?
Well, usually when we've passed through the purpose of, so we use Jira, we have sprints, we have tickets, then we write tickets. Usually when we write the tickets, we'll go like, here's the purpose of what we want our software to do. We have things called acceptance criteria, which is like, for this ticket to be done, once we're broken down to this line has to be complete, this line has to be complete, and this has to be done. What then happens with a lot of developers is they get really into the weeds of like trying to get this to fix, trying to work behavior you want it to do, trying to get the logic right, trying to get it to sort of be what is the utopian sort of dream of like perfect software. But you have got the acceptance tests. That is the purpose, the acceptance criteria. That is the purpose of what you're writing. It's to fulfill that purpose. What's the acceptance criteria so you can move on to a different ticket. And that usually is pretty good. It then becomes like, we have things like the right shape of data that comes in. If that matches up what the logic we wanted to do and then passes on, we think about those things before we actually write the software. So the documentation, the actual like the shape of like the array or the object or what have you, that's something we're kind of mindful of as we go. If actually it hasn't been a massive concern because we've thought about it ad nauseum about what we want the software to do. And usually if we've done it relatively simply, then we know it's kind of small, it's not massive, then it becomes pretty simple to get like the addition function. It's very simple, but if we've simplified our software enough and it's short enough and small enough and modular enough and aligns with solid design principles, then it's not really a massive concern. If it's bigger than that, then usually we have like integration test acceptance, but it hasn't necessarily been a concern for myself. But yeah, great question. Yeah. How are we doing for time? How hungry are we? Like hands up, who's hungry? Okay, right. I'll take 2 more and then pizza. Right. Who had? Yeah. Yes.
Working, so I'll just have to speak loudly.
It's a great microphone.
After university, like you guys, was a software engineer.
Yeah.
And I know this was before you were even born. Okay. And I'm impressed with how software engineering has moved on since then. But at that time, we had a rule of thumb that essentially by the time you write your code, your acceptance test, your debugging, your documentation, productivity was essentially 1 line of code per hour.
Right.
And that was kind of like industry standard. So is it better now?
Broadly across the entire industry. Again, it's complicated. I can only speak a little bit from my experience and my friends and my colleagues' experience. I know of a company, which I won't name, I'll know of some companies, which I won't name, that have requirements about a certain number of PRs in a day. I think there is a good purpose behind that because you want to be timely and efficient with the software that you write. But I think it slightly misses the point of trying to write. Basically, I think it's an arbitrary number. So the idea of writing certain lines of code in a day seems horrifying to me. There's genuinely, I don't think it speaks out badly of myself, but there are days where we don't write any code. We parse through documentation, we talk about what we're trying to do, and then we write the software. And it's trying to get that software to be, we're trying to reduce the amount of software we have to write, so that when we do get to writing the software, it's relatively simple to interpret what we're trying to do. That doesn't necessarily solve all the problems when we come to writing whatever we're writing, but we don't have those arbitrary deadlines. I think they might exist across the industry. I've heard a few times about that, but I haven't come across it personally. But yeah, great question. If there's, okay, I can take one more. Holding up pizza. Oh yeah, yes.
What is it? In first year, we also work with a very strongly typed language, Haskell, and we do a bunch of type system stuff.
Yep.
But a lot of type systems get invented, and then nobody ever checks if that lowers the number of bugs.
Okay.
So I was wondering what your experience is in actual industry with, are type systems useful to you? If so, how much of a type system is useful?
I'll say this. I don't know what a type system is. No, I'm aware of types. I'm aware of like TypeScript, of being tightly typed languages. I'm aware of like Java and what have you. And I think they are really good at adding additional rigor to what you're building. At the moment, we use JavaScript. I have used TypeScript before. Again, there's additional learning curve, but what it does, it adds something more of a dependable approach to what you're building. I can talk about TypeScript as a reference if you want. If you're writing in JavaScript and you shift to TypeScript, it is basically a new language, but it adopts a lot from JavaScript. What I found that really useful for is that when you're writing systems that are quite complicated and you're trying to interpret what the expected results are going to be, the type of what you're passing through is pretty fundamental. So even when it comes to like objects and arrays with certain strings, with certain values, in certain positions in that array, what that helps with is go like, this is wrong, this is incorrect. I have an addition function there that has a test to see about what value you're passing into the function. That doesn't necessarily need to exist if you have TypeScript, because it says the type is a string. It doesn't build at all if there's no, if the number has been passed through. Sorry I couldn't answer your question, but that's the closest reference I've got. Cool. I'll call it there, and we can have pizza. Thank you very much, everyone. Cheers.